Students, today chapter is on the detectors. This is a beneficial lecture for students of radiography and radiotherapy as well as residents. It is difficult to design an instrument that can directly measure the radiation. Type of radiation is like gamma rays, X-rays, beta rays, alpha rays. We cannot measure directly, but we can measure the effects by measuring the ionization when the radiation will interact with that material. Radiation detection instrument has three parts. One is a chamber that is called detector chamber. The main is the power supply from where we applied the voltage, and it is called amplification system also. Third one is a measuring device or a meter on which we can take the reading. We can see the reading of the current flow through the chamber. Principle of radiation detection. What is ionization? Ionization is production of the ion pairs, one positive, one negative ion. Ionizing radiation has enough energy to remove an electron from an orbital electron from an atom that will create ion pairs. This is a basic system for measuring ionization. First, battery, that is called power supply. In circuit, it will effectively create one positive electrode and one negative electrode at the detector. Center wire of the electrode is called the positive electrode, that is act as a anode, and walls of the chamber act as a negative electrode. So positive electrode is isolated from the negative electrode. When ionizing radiation interact with the material of the detector that is filled with the gas, so then it will form ion pairs because of the voltage differential. Then what will happen inside the chamber? Positive ion pairs will goes towards the wall of the chamber and negative ions will go towards the anode. So this ion collection result as a current flow through circuit. So when current will flow through a circuit, then measuring device will deflect in proportion what amount of radiation ionization take place. So it will indicate the amount of radiation present in the chamber. When first ion will reach to the electrodes, then very small current will flow. When more and more ion pairs will reach, then magnitude of the current will increase. But when it reaches to the peak, ion will start decreasing, then current will also begin to decrease. This is a graph that is plotted against a time of a current, amount of current plotted against a time. This curve like thing is called a pulse that correspond to, this is called one pulse, means one particle entering the detector. So size of the pulse will depend on the ion pairs, how many ion pairs produced and collected in a detectors. So pulse size will vary on the ion pairs. If the more ion pairs collected, then size of the pulse will be large. If fewer ion pairs are collected, then the pulse size will be small. There are some factors that will affect on the ion pairs and pulse. So there are 6 factors. Factor 1 is the type of radiation. What type of radiation is passing through the chamber? If radiation is of a higher specific ionizing radiation, then it will produce more ion pairs, then the pulse will be large enough. For example, alpha radiation is 20 times higher specific ionizing radiation compared to gamma radiation. So the pulse will be larger than the gamma radiation. Factor 2 is the density of a gas in a detector. The detector is filled with what type of a gas? If it is more dense, then it is under a great pressure. So more ionization interactions will occur because we have more atoms available. So the pulse size will be large. Factor 3 is the incident energy of a radiation. What type of radiation is entering into a detector? If it is a gamma photon of low energy, then very few times it will interact before dissipating its all of its energy So that will result a few ion pairs. So the pulse size will be small. On the other hand, if gamma photon of high energy may enter in the detector, then it will interact many times. So the pulse will be larger because it will produce more ion pairs. Factor number 4 is the type of the gas chamber filled with. If gas is easily ionized, then we will have more ion pairs that will result a higher pulse. So generally ion chambers are filled with a counting gas, that is the argon gas. Fifth one is the size of the detector. If detector is small, then some of the energy will pass through without interacting with the inside the detector. So we will not have any pulse. On the other hand, if chamber is large, then it will allow gamma photons to completely dissipate its energy. So we will have the large pulse because we have many ion pairs. The last factor is the voltage that is made. The voltage applied across the electrodes. If we applied a low voltage, then electron pairs that produce, they will recombine before reaching the electrode. They recombine with each other, so no pulse will produce. If the voltage is high, then gas amplification will occur. So what is gas amplification? Gas amplification is a production of secondary ionization by initial ions produced by the incident radiation. Voltage should be high enough so that electrons are accelerated towards the electrodes. If electrons gain enough energy, they will start to produce ionization themselves that could result in an avalanche effect. So these 6 factors will affect on the ion pairs production and the size of the pulse. They are extremely important. If pulse produced in that detector is too small, then the measuring device will not able to sense it. Size of the pulse will tell us the type of the radiation entering into the detector, that referred to as a pulse height analysis. So it can tell whether that radiation is beta, alpha, gamma by counting the number of pulses and by the size of the pulses, and we can determine the amount of radiation that enter into the detector.